Okay, hello and welcome to the second part of our video. The last video, hopefully you watched that, in which we reviewed how to do inverses. And on this one, we're actually going to now do the inverse of a quadratic. So we're going to run through those same steps we talked about earlier. So this one I did not set equal to f of x, but I could definitely switch that out real quick just so that you had it in that form. So it doesn't matter if again it gives you y equals, that just allows you to bypass the first step. So the first step again is to change the f of x to y. Second step is to switch the x and the y. And the next step is to solve for y. And so this is actually a x squared or a y squared problem. And again, to solve that for y, we would need to square root both sides. Okay, so if you'll remember in the past when we have done and we square root both sides, we put the plus and minus out in front. Now we're going to talk about that piece here in just a second. So let's just go ahead and look at the graphing of this. Okay, so we're going to graph first the parabola y equals x squared, which would have a, the vertex would be at the origin. X-intercepts is at the origin, so I could plug some numbers in. So if I did 1 would be 1, negative 1 squared is also 1, 2 squared would be 4, negative 2 squared would be 4, okay? And so the parabola that I'm looking at looks like this, okay? Now, here is the next piece is to, again, put in my dotted line with the y equals x line, okay? Now, I am going to use the fact that if I flip the points, I'm going to get my other equation. So I'm not necessarily going to look at my equation that I just calculated. I'm going to reverse points. In other words, what I mean by that is 0, 0 still stays 0, 0. 1, 1 would still stay 1, 1. This is 2, 4, so I'm now going to go to 4. 1, 2, 3, 4, 2. Okay? Over here on the other side, I am at a negative 1, 1. So it would be 1, negative 1, and it would be a negative, 4, negative 2, okay? And I would draw my graph. Okay, that's really bad sideways, okay? Now, I want to talk about this before we continue on. Let me go back in and redraw that, okay? Because what I want you to notice here is when I look at my parabola, my original one, it is a function, okay? It passes the vertical line test. But when you look at what I have now drawn as my inverse function, the parabola that is now laid on its side, it is no longer a function, okay? No longer a function. So what we have to do is we have to do what we call a restricted domain, okay? And basically what that's meaning is I can't look at the entire parabola because its inverse is not a function. So what I could do is I could either look at the right half, maybe this will work. I could either look at the right half, there we go, of my graph, and then its inverse, which would be a function, or I could look at the left half and its inverse, which would be a function, okay? So I have to decide which one. Now, normally, when you see this, not all the time, but normally when you see this, and I restrict the domain, we usually will say look at the positive half of it. So what I'm telling you is we're only going to look at where x squared is, where the x is greater than 0, okay? Which when I do that, then that is also on my equation restricting my answer, so I don't have both positive and negative. I only have the positive root of it, okay? Because again, I can't take the square root of the negative, okay? So what does that do to my graph? Well, let's see if I can fix it here for you without messing things up too bad. So on my graph here, again, I'm only going to have that half, okay? And on my blue one, again, get rid of this, I'm only going to have the bottom half, or the top half. Now, these are in fact inverses of each other. And they are both functions because they both pass the vertical line test. So the only way a quadratic can be or can have an inverse, okay? The only way its inverse can exist is if I do a domain restriction. Okay? Now, how do I know where my domain restriction is? It is going to be the x value of your vertex. Okay? The x value of your vertex. Okay? So, let's do another one. So, give you a little bit harder one. So, we're going to do f of x equals x squared plus 2. We won't move it up too high. And this domain restriction, again, is going to be x is greater than or equal to 0. Okay? Because, again, my vertex is going to be at 0, 2 in this case. So, first I'm going to calculate it. So, my first step would be to change the f of x to y, switch the x and the y, and then solve for y. And again, solving for y, so I'm going to square root both sides. Okay, and since I'm only looking for the positive, I am going to only have the positive root of it. Okay, so we're going to start with the original, x squared plus 2, so that would have a vertex at 0, 2. Again, if I plug numbers in, if I have 1, that's going to give me 3. If I have 2, that would give me 4, 6. So 2, 6. Whoops. Which it just moved it up to 3, 4, 5, 6. There we go. Okay. So again, I'm only going to, again, that should curve, but not be a straight line. So there is my original. If I do the inverse of it by just putting in the inverse points, instead of 0, 2, I'm going to do 2, 0. Instead of 1, 3, I put 3, 1. Instead of 2, 6, I'm going to put 6, 2. Okay? And again, if I dot in my y equals x line, those should look like inverses of each other. Okay? Now, according to whether or not we have, which we should have, looked at, or maybe not, looked at the graphing of a radical, but again, if you will remember, when we our vertex form of a parabola, okay, that whatever is inside here moves it to the left and right. So it's also the same thing in here. So this in vertex form would be, move that there. Whoops. Well, there we go, plus k. Okay, so it's going to do the same thing. So whatever is in here is going to move it to the right, which it did. And again, whatever here is going to move it up. Well, there's nothing, in this case, out there. There's no plus to it, so it did not move it up. It stayed. Okay? So that is the inverse of that quadratic. Okay, let's do another one, and this one we're going to do it in vertex form. So we're going to do f of x equals, and let's do x plus 1 squared minus 2. And again, my restriction here would need to be a -1 because that would be where my vertex would be at. So let's just go ahead and graph this to start off with. So I am going to have a vertex, again, at a -1, -2. I am going to, you could do x-intercepts if you wanted to, or you could just plug a point in, or maybe just do a y-intercept. So your y-intercept here would be 0, what would that be? -1. So 0, -1. I could do an x-intercept again if I wanted. So I'm going to move that over. That is going to give me a decimal. Okay, so x equals a -1 plus or minus the square root of 2. And so I could either do that, or I could put in an x value. That would be the other way to do it. So you could calculate that as a decimal again, or I could just come in and put in, let's say, okay, I want to know where it is at 1, and that would be 2 squared, be 4, minus 2 would be 2. So at 1, I'm at 2. Okay, so either way you want to do it works for me. But as you can see, when I come in here and I draw this, again, it's going to hit, well, mine's a little bit off, so maybe I'll redraw it. You're going to have that hit. So be sure you do curve this. There we go. Okay, so that's what it's going to look like. Now, I'm going to dot in my y equals x line. Whoops. It's kind of a bad dot. There we go. Okay, and again, if I do just reflection of points, I would have -1, -2. So I'm going to do a -2, -1. I have 0, -1, so I'd have -1, 0. I have 1, what did we say that was? 1, 2? Did I draw in that right spot? I put in a 1 and I said it was 2. I don't think I put 1, 2, did I? That's my bad. Go back to my green line. I graphed, it's supposed to be graphing 1, 2. Let me go back and get this here. That was my bad. Did you guys notice that I plotted that point in the wrong? Oh, that was that one. Here it is. There it is. No, I guess I did. That was my 1, 2. There we go. Yeah, that looks like a straight line. Okay, I will get it this time. No, I won't. I just messed up my whole graph. Is that where that was at? I think so. I need to quit messing with it, trying to get it perfect. Did I fix my graph? Let's see. Vertex was at a -1, -2. There we go. And then I had a point at 1, 2. There we go. Okay. And that was there. Okay. Anyway, there you got it. Close enough. And then again, I was doing the reflection was what I was trying to do here. And I should have had 2, 1. There we go. Okay. Hopefully that makes sense. There we go. Somewhat in the ballpark. I apologize for that. But you should be able to tell that those are reflections of each other. Now, again, let's go ahead and calculate out the actual inverse. So that's just looking at a graph. And it's the graphs, especially if you do inversing of the points, is easy to get your graph. And you can always do that. But now we're actually going to go through my inverse rule. So again, I'm going to switch the, change the f of x to y. I'm going to switch the x and the y. And then I'm going to solve for y. So I'm going to move the x over, the 2 over. And then I'm going to square root both sides. Move the 1 over. Negative 1. Whoops, why did I put an equal there? Minus 1. And again, that's equal to y. So f inverse of x equals the square root of x plus 2 minus 1. And I don't know if on this one up here if I did the f inverse. But anyway, when you look at this again, guys, this is your movement to the left in this case, and your movement down. So what that means is that my vertex of my radical should be at a -2, -1, and -2, -1. There it is. Okay? If you just had, again, the radical and you needed to graph it, again, you could do the same thing that we've done before. You could find your x and y intercept by just solving your equations. Okay? So that would be an example, again, of a quadratic with some translations, transformations that happen, and what the inverse would look like. Now, very rarely, none in here do we take standard form and do the inverse to it. So you will not have one like that. Again, you could do it. You would need to complete the square on it, on there, because you're going to have, again, when I switch, and when you complete the square, you're actually completing the square then on the y, not on the x. Okay? And so it would be your x value, and then you're going to, again, complete the square here to solve for the y. Okay? And again, I'm not going to ask you to do that, but just to know that that is how you would do it. So you're just going to pretend you're solving for the y there, do a completing of the square. Okay? So hopefully that makes sense on how to find the inverse then. And this is also proving to you that the inverse of a quadratic, an x squared, is a radical. They are inverses of each other.